So today we're talking about rhombi, that's the plural for rhombuses, rhombi, and we're talking about rectangles, okay? So first of all, let's go through a couple of things that we know, okay? So if we're going to look at Common Core, today is the G for geometry, CO for congruence, and then it's number 11, and it is basically proving theorems about quadrilaterals. No wonder I can't spell that. It's a big word. So, characteristics of a rectangle. So before we do anything, let's call it a parallelogram. So right off the bat, it's a parallelogram, okay? Parallelogram. So if we say it's a parallelogram, then all of those other characteristics that we know about it are going to come true, okay? So if we put down that it's a parallelogram, then we already know that opposite sides.
Please excuse the interruption. Our copier is down in the office, so please.
Of course it is.
Thank you.
Of course it is. Brand new copier, brand new. I know. It's just crazy. Anyway, moving on. So we know if it's a parallelogram, all the things, opposite sides are equal, opposite sides are parallel, right? Opposite angles are congruent. We know that diagonals bisect each, okay? But then we also know a few other things about a rectangle, okay? Obviously we have 4 right angles. We knew that. We knew that way back in probably 2nd grade, right? Probably. And then the thing that might be new is that diagonals are congruent. That's something a little bit new, okay? All right. What about a rhombus? Well, if we call it a parallelogram, then all of those other things that are parallel, same thing, right? Opposite sides are equal, opposite angles, opposite sides are parallel, opposite angles are equal, and diagonals bisect each other, okay? Those we know. But what else do we know about a rhombus? Well, it's got 4 congruent sides and a couple other things that we know about a rhombus. We also know that diagonals are perpendicular. Diagonals are perpendicular, and we also know that diagonals bisect the angles, and that diagonals bisect the angles, okay? And real quickly, I'm going to draw a picture of both, and just so we have it in our notes, we can see what they are. So if I go draw my little rectangle here. Okay, the main characteristics, we already know 90, 90, 90, 90. And we already know things about a rectangle. That's equal to that. That's equal to that. Those are things we know. But the one I want to put in more than anything are the diagonals. So if I draw my diagonals, draw that one in, and draw that one in. I want to put the fact that those are equal. So if I go A, B, C, D, right at that, I'm going to say that AC is congruent to BD, okay? All right, that's something that's maybe new, maybe not, okay? And now let's look at a rhombus, put down the special stuff on the rhombus. Let's say one of these. There's my rhombus. There's my rhombus. So, I mean, on a rhombus, what we do know for sure is 4 congruent sides. All 4 sides are equal. But more specifically, what we want to talk about is the fact, are these darn diagonals? So let me draw those diagonals in. We'll talk about, okay? Make sure I label it. There's that. So we get a visual. I always like a visual because if I can see it, I can do it, right? If I can see it, I can do it. 90 degrees, that's a biggie, okay? That's something new, right? And we also know that they bisect the angles. And that's something new. That angle is equal to that one. That angle is equal to that one. Those 2 angles are equal, and those 2 angles are equal, okay? And that's what makes it unique about it. Okay, now, the square. Now, we haven't really talked much about the square, just bit by bit, but let's take a look at a square. So I like to give one of 2 definitions for a square, okay? One of 2 definitions. Either a square is a rhombus with 4 right angles. Okay, now rhombus, 4 equal sides. Yeah. So if I take this thing and straighten it out, it makes it a square, right? If I take this thing right here, straighten it out, it makes it a square. Okay, that's one definition. Another definition I like to do is call it a rectangle with 4 congruent sides. Okay? So if it's a rhombus, boom, 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 with 4 right angles, yeah, that looks like a square, doesn't it? Or if it's a rectangle, which we already have the 90 degrees, with 4 equal sides, then obviously it's a square, okay? Okay, so those are all our definitions and our characteristics. Let's go ahead and do some things with this, okay? Right off the bat, number 1, it's a rhombus. So yeah, I mean, opposite sides are equal, but then every side's equal, right? So let's just set this ST equal to SR, right? ST's got to be equal to SR. So I know ST is equal to SR. I know that because it's a rhombus. So let's take our 4x plus 7 and set it equal to our 9x minus 11, right? And we'll just solve for x. Go minus 4x minus 4x. 7 equals a 5x minus 11, right? Plus 11 plus 11. So if I go plus 11 plus 11, I get 18 equals 5x. Divide by 5. Let's see, that's probably going to be 3.6, I'll bet. Let's see if my brain's any good today. 18 divided by 5. Yeah, 3.6. I can still do math. Thank goodness. Now, each side, all we have to do is find one of them because they're all equal, right? I mean, really, all we got to do is take this 3.6 and plug it right in there or into there, but I'm just going to pick the easier one, right? I mean, because they're all equal, so I'm going to have 4 times 3.6 plus 7. I'm going to use my calculator. Yep. 4 times 3.6 plus 7, and I get an answer of 21.4. Okay, so all sides, all of them are 21.4, 21.4 all the way around. Thumbs up? Easy? Yep. Good. Okay. Example 2. Okay, ABC is a rhombus. Okay, find each measure. Now, this is one where you got to remember what I said. Something important in a rhombus.
Is it
90. There's 90 right there. You guys okay with that? That's 90, right? So that's 90. We could probably figure out y is, right? So that's 90 degrees. My little box right there. So let's go right off the bat and say, okay, I can do that. 2y plus 10 equals 90, right? Easy. Minus 10 minus 10. 2y equals 80. Am I going too fast?
just a little bit?
Okay, I'm going to start trying to slow down, okay, Jaden? So I knew it was 90 because it's a rhombus and they are perpendicular. So I set the 2y plus 10 equal to 90. Minus 10 minus 10 makes 80. Divide by 2, y is 40, okay? So if y is 40, that's not the answer, but we're getting closer, right? So if y is 40, let's take my 40, and I'm going to put it right into here. I already know that that's 90, right? So if I put the 40 right here, then this angle right in here is 42, right? Because 40 plus 2, which means this angle here has got to be 42 also, right? Which means this angle down here is 42, and this angle here is 42, right? We know those are equal. Now what about, let me get a different color so you can see it. Different color, here we go. What about this angle? What about angle CD? I don't know what that is. What about this angle? What about that angle right there at angle D?
Well, couldn't you just add 90 and 32 together? 90.
Yes, that's the long way, but totally correct. I'm going to show you a shorter way. Yes. Katie says, because I know a triangle. You guys see the triangle? In a triangle, 180 degrees, right? You guys agree? So Katie is totally right. Katie said, well, let's just go 180. We'll subtract 42, and we'll subtract 90, and we'll get the answer, right? Now, there's a faster way, okay? Little reasoning, little logic, okay? If 90 of it's already used up, then the other two have to add up to what? Yeah, isn't that faster? Does that make sense? I mean, if you know there's 90 here, then these two have to add up to 90. Isn't that faster? So how about just 90 minus 42, okay? Do you like that better, Katie?
Yeah.
You're correct, by the way. 100% correct. I just want to show you a faster way. So 90 minus 42 is probably 48. So you get 48 degrees, okay? That's faster. So one more time, on film, on the record, you were right, Katie. There you go. Ready to turn the page? Okay. Oh my goodness, look at that. It's one of these proof graph thingies, okay? All right, so let's graph it and figure out what we have to prove, okay? So, -1, 0. There's A, right? -3, 1, 2, 3, 1, 2, 3, 4, 5. There's B. C is at 2, 1, 2, 1, 2, 3, 4, 5, 6, 7. There's C. Okay. D is at 4, 1, 2, 3, 4, and 1, 2. There's D. Okay, let me connect the dots. So show it's a square. Yeah, show it's a square. All right. Once again, there's an easy way and there's a hard way. Easy way, hard way. What would you pick? Easy way or hard way to prove it? Easy way every day, right? I agree, totally. So here's the hard way. If we call it a rhombus with 90-degree angles, then we're going to have to somehow prove the lengths, which means Pythagorean theorem, which we could do. We could do that. If we have to prove that that's equal to that, it's equal to that, we could do that. And that will work, okay? But how about we prove it's a parallelogram, okay? A parallelogram. Oh, we may have to prove equal sides. Darn, we might still have to do that. Yeah, we may have to do that. But that won't be too bad. I was going to say a parallelogram with 90 degrees, but that's a rectangle also, right? Sorry, we're going to have to do a little bit of work. So let's figure out what the lengths are. So we may have to find out what the lengths of AB, we have to find the lengths of BC, CD, and AD. But that's not hard. That's not as bad as I thought. You know why? Because I know how to do the Pythagorean theorem. Do you know how to use the Pythagorean theorem, right? So I make a little right triangle right here. You guys see my little right triangle? Right? If I did Pythagorean's theorem, I'd have, well, okay. I'd go, okay, I'd have a squared plus b squared equals c squared. So 1, 2. I'd have 2 squared plus 1, 2, 3, 4, 5 squared equals c squared, right? So I'm really going to take the square root of that because that's what, to do Pythagorean's theorem, we'll get c really as the square root of that. So it's going to be the square root of 4 plus 25, which is square root of 29. Okay, 4 plus 25, square root of 29. Well, let's just leave it square root of 29. I could use a calculator and get a decimal inch, but I want to leave it just because I'll do the same thing with BC, CD, and AD, okay? And if I get square root of 29, square root of 29, square root of 29, they're all equal, right? So let's find BC. So BC, oh, I'm sorry, I just did the wrong one. It's all good. Okay, let's do this side. Okay? Yeah, it should be the same. 1, 2, 1, 2, 3, 4, 5. So it's still the same thing. Square root of 2 squared plus 5 squared, which we know is square root of 29. Okay? That's nice and fast. You guys agree with that? Same triangle, right? And how about this one? CD. It looks like it's 1, 2, 1, 2, 3, 4, 5. So, you know, same thing. 2 squared plus 2 squared plus 5 squared, square root of 29. Same triangle, right? And then finally we'll get AD. 1, 2, 3, 4. 1, 2, 3, 4, 5, 1, 2. Same thing. 2 squared plus 5 squared, which is square root of 29. So it's got to be at least a rhombus. Okay? It's got to be at least a rhombus. At this point, we know it's a rhombus. Okay? Okay, know for sure it's a rhombus, but we don't know it's a square yet. So to get square, we need 90 degrees. Okay, that's easy to prove. You know why? if the slope of CD is the opposite slope of BC, if the slope of this is the opposite slope of that, they're perpendicular, right? Remember that? So this, oh, sorry, Katie. Thank you. So if this slope is the opposite of this slope, 90. If this slope is the opposite of this slope, 90. If this slope is the opposite of this slope, 90, right? So let's figure out the slopes. Okay, so what are the slopes of AB? What's the slopes of BC? What's the slope of CD? What's the slope of AD? That's easy. We can count those, right? So the slope of AB. Let's count. Am I going too fast?
Yeah.
Okay. I'll slow down for a second, okay? So we're going to count to get the slope because slope is just rise over run, and we already have the triangles in front of us, so we already know it, right? So the slope, ready? Up 2 over 5. BC is 2/5, okay? AB is down 1, 2, 3, 4, 5 over 2. Down 5 over 2. Those are perpendicular, aren't they? Opposite slopes. Negative 5 over 2, 2 over 5. Those are opposite slopes, okay? CD is down 5 over 2. And AD is going to be up 2 over 5. Those two are perpendicular. So we know for sure that it's got to be, at this point, it's got to be a square. It has to be a square. We have the proof. We first proved it was rhombus. Then we proved we had perpendicular lines, which means 90. It's got to be a square. Okay? All right. Now, 2 to 23 might be a lot. So let's change it to 3 to 23 odd. How's that? Does that sound better? And that's not that many problems. That might be about 11 of them, huh? Shayla's like, I can do that, Mr. Davies. I can handle that, right? Okay. Let's change it to